All right, thank you, everybody. I want to start by just thanking all of you for inviting me to join you today and host a conversation about how our calling as Christians to care for God's creation needs to be fulfilled by working together and individually to solve the global climate crisis. So over the next 3 Sundays, we're going to talk about what is happening, why it's happening, and what we can all do about it together. So just a brief introduction. I'm Jeff Thiel. My mother, Judy Thiel, is sitting over at the table there. And our family grew up in this church, and as we speak today, I'm having flashbacks to confirmation with Pastor Rolander, I think in this room. So it's good to be back here and be with all of you today. So I think that's what we need to get started. I'm going to make this as engaging and interactive as possible. I've built in time for all of us to talk to each other and ask questions. But of course, if we're not going to get to all the questions, so if you have things you want to talk about afterwards, just let me know and we'll do that. So to get underway this morning, I just realized I came in without probably the most important tool, Bible. So if someone could please find me a Bible this morning, if you've got one handy, that would be great, because we're going to need it as we get started today.
So Jeff, can you provide some of your background?
I'm just going to move.
Yeah, let me tell you a bit about how I came to be involved in this work I'm doing right now. So the past 2 years, I've made it my full-time occupation to figure out how we're going to reverse global warming. When I got into this because I had a break between other things I was doing, and I got recruited to participate in a fellowship program called the Conservation Philanthropy Fellowship. And I took advantage of that time to do a really in-depth, structured investigation of something that I knew was a problem, but I didn't really understand all that much about it, and that's climate change. So in the fall of 2016, I did this deep dive, and I came away from that experience alarmed, because I had no idea how serious and how urgent the problem really is. But I also came away hopeful, because what I learned is that we have all the solutions we need to solve this problem. We just need to use them. So with that in mind, over the next couple of Sundays, we're going to spend a lot of time talking about solutions. But we're also today going to talk a little bit about the science behind climate change and what's actually happening to make sure we all have that sort of shared understanding of what's going on in our world right now. So with that in mind, I want to start.
What's your technical background?
So I have degrees in economics and history from the University of Washington, and then started my career in management consulting. Went to Wharton for an MBA, and then spent a number of years at Microsoft and then at other software ventures in the area before doing this Conservation Philanthropy Fellowship. So I want to start this morning with Scripture, because Scripture has a lot to say about our responsibility as Christians to take care for God's creation. And now, if someone else could also get a Bible, it would speed things up a little bit, because I'm going to have to find each of these passages one by one. I wanted to start us out this morning reading a few of the passages that I think are pretty good examples of what the Bible has to say about how we should relate to creation. Now, while we do this, I want to ask each of you to think about the words that come to mind that for you best describe how God intends us to relate to the rest of creation. And then also think about the words that come to mind that best describe how we currently are taking care of creation. And we're going to talk amongst ourselves about those in just a minute. So creation, starting with Genesis chapter 2, verse 15. The Lord God took the man and put him in the Garden of Eden to till it and keep it. And then in Genesis 9, verses 8 through 10, these are both very familiar stories. Verse 8 through 10. Then God said to Noah and to his sons with him, "As for me, I am establishing my covenant with you and your descendants after you, and with every living creature that is with you, the birds, the domestic animals, and every animal of the earth with you, as many as came out of the ark." Does someone have Leviticus or Psalm 24 handy?
I have Psalm 24.
Psalm 24, thank
I
you.
can read it.
The earth is the Lord's and all that is in it, the world and those who live in it. For he has founded it on the seas and established it on the rivers.
Thank you. Does someone have Leviticus handy? Or are you going to make me find it? It's Exodus, Leviticus, right? 26. Okay. Verse 3. Okay, here we go. "If you follow my statutes and keep my commandments and observe them faithfully, I will give you your rains in their season, and the land shall yield its produce, and the trees of the field shall yield their fruit. Your threshing shall overtake the vintage, and the vintage shall overtake the sowing. You shall eat your bread to the full and live securely in your land." And lastly, in the New Testament, Colossians 1, verses 19 through 20. Thank you.
I just have to be able to read it. For in him all the fullness of God was pleased to dwell, and through him God was pleased to reconcile to himself all things, whether on earth or in heaven, by making peace through the blood of his cross.
Thank you. So what I'd like to spend the next few minutes is just having you talk to your neighbors and ask each other. This is going to be a listening exercise, because in a moment I'm going to ask you to tell me what your neighbor said. Not what you said, but what your neighbor said. So I'd like you to talk to your neighbors and ask them what's the one word that they think best describes how we should relate to God's creation. And then what's the one word that you think best describes how we're currently doing that. So I'll give you a couple of minutes. We'll spend 3 minutes doing this, so just talk to your neighbor and be prepared to volunteer to share what you learned. Why don't we come back together?
Oh, so the one that says how we actually live could be like what Julie was saying about
And then I'm going to ask volunteers to share
we're
what
not
they
always
learned.
responding for.
Okay, can I have everybody join us? Thank you. So I'll just take volunteers. Who would like to start by sharing what their neighbor said was the one word that best describes how we should relate to creation, and the one word that they thought of that describes how we're actually doing that? I'm just going to write some of these down. So can I have a volunteer?
How we should be responsible.
Responsible. Okay, that's a great word. And what about how we are doing?
Different color, please.
That better?
Yeah.
Okay.
Why is it doing that?
And then the word that your neighbor said best describes how we actually are taking care of creation.
Irresponsible.
Irresponsible. Okay. Well, that's pretty clear. Who else? You want to share?
Wisely and exploit.
Wisely. Okay. Exploit.
I'd say reverence. Reverence.
Reverence over here, I assume.
How you describe what I said.
How about on the other side, how we're currently doing?
Lack of passion. Actually, I don't know a word for that. A lack of passion. I don't know how to describe that.
I'll go dispassionate. Or uncaring? Is that right? Uncaring.
Respect and careless.
Respect and careless.
Steward.
Steward? Thank you. That's over here. What about on the other side?
place of?
Place. Well, thank you. I think those are pretty representative of, I'm going to move us on in a moment here, but if you...
Caretakers and destroying.
Caretakers and destroying.
Consumers.
All right, I'm going to move us on here for a moment because I think these are really good examples of the fact that there's a pretty big disconnect between how God wants us to take care of creation and based on our own observations here this morning, how we're actually doing it that.
Amen.
And I share that every day because for me, the word that immediately comes to mind is stewardship. And I believe that we're entrusted with the care of God's creation. And yet, every day, I feel like I'm in conflict. That's the word that I would throw in here. And the source of that conflict is something I want to spend a couple of minutes talking about. Because for us, I think almost everybody would say, yeah, I want to be taking good care of the planet and the rest of creation. But every day, our desire to do that is in fundamental conflict with the economy in which we function. All the goods and services, nearly all the goods and services that we consume every day have a tremendous amount of waste, heat, and carbon dioxide involved in their creation and distribution. And it's almost impossible to think about all the different ways this happens. But I want to share a few of those with you today, just to give you some examples. So let's break it down for a moment. We extract things, mostly fossil fuels and other materials, often in very remote places. We transport them huge distances to bring them to some site where we then transform them. We either burn the fossil fuels or we use them as inputs to create other things. And then we take either the energy that we create with the fossil fuels that we just burned or the goods that we created, and we in turn ship those huge distances to the ultimate point of consumption where you and I are eating and wearing clothes and living in a house and driving our car every day. And this global supply chain that we're all part of right now emits huge quantities of heat and carbon dioxide at every one of these steps. And I'll just give you, it blew my mind when I first started learning about this because I had no idea, for example, let me focus in on a couple. So when we drill for oil and take oil out of the ground, a lot of natural gas comes along with it, but many oil rigs aren't prepared to process that, so they just burn it. It never gets used for anything, it just gets burned. And as much as 25% of all the natural gas that's taken out of the ground just gets burned without ever going to any sort of use. When we frack for natural gas or take it out of the ground in some other way, it leaks. And the quantity of that leakage is something that hasn't really been investigated until quite recently. And what we're learning now is that the amount of methane that leaks could be so much that it makes it more damaging for the environment than burning coal. So we hear about how natural gas is this great solution, but the truth is we don't actually know, and the evidence is starting to tell us that it might actually be the opposite. And then when we burn coal or natural gas to create electricity, about 30% of the energy that's in the coal actually gets translated in electrical energy potential. And with natural gas, it's more, it's 40 to 60%. And then when it's distributed via transmission line, there's a certain amount of loss, 6 to 8%. So by the time you go to turn on your light bulb, the majority of the energy in that original material has been just wasted. And when it's burned, it's releasing heat and carbon dioxide. So that's one thing that I didn't understand the magnitude of that. I also had no idea that concrete, which is the second most used material in the world after water, which has aggregates, fines, water, and cement in it, where cement is the thing that holds it all together when it dries. That cement, every ton of cement that's created releases a ton of carbon dioxide. And the amount of carbon dioxide that's released is a consequence both of the energy that's used, because to create cement, you cook limestone to like 1,400 degrees in a massive kiln. And when you do that, that takes a ton of energy, but when you do that, it also breaks down into calcium carbonate and carbon dioxide, and the carbon dioxide just gets vented into the atmosphere. So cement is a huge contributor to the problem, and the same process occurs with steel. And then plastics come from oil, the derivative of oil. And unfortunately, most plastics today end up in the environment. So they're not necessarily being burned and creating problems that way, but they're also getting broken down in the environment over a long time. Trucks idling at truck stops. I had no idea that trucks are just left on all night to keep the drivers warm and keep the engines functioning well. And I looked at investing in a company that's trying to solve that problem, and what they shared with us is that when you add up all the burning of the idling that happens around North America, it's over 1 billion gallons of fuel per year that's just being burned when a truck's just sitting there at the truck stop. When we drive around in our cars, internal combustion engine cars, only about 20 to 30% of the energy that's represented by the gasoline you put in the tank actually results in moving the car down the road. The rest is being released through heat and friction. So being used up through heat and friction. So it's a very inefficient way to get around in that respect. There's a lot of heat and carbon dioxide that's released through that process as well. Now, when you add all of the activity up across the globe, and there are now 7 billion of us on this planet, it amounts to over 37 billion metric tons of carbon dioxide every year. And this number is still increasing. And that's more than 5 tons per person. I can't even really get my head around what that looks like. Does anybody have a sense for what a ton of carbon dioxide looks like? All right, so we'll spend a minute on that. It's kind of interesting. So, carbon dioxide is an odorless, colorless gas. And it's hard to think of gases as having weight, but they do, because everything, in the Earth's gravitational field, every molecule has mass. If you are at sea level and you're talking about a ton or 1,000 kilograms or 2,200 pounds of carbon dioxide, that is about equivalent to a sphere 10 meters in diameter. So, I don't know, maybe there's 2 of them on each side of this room and 4 of them going, if you went all the way back. Maybe less, maybe more than, fewer than that. It's a big amount. So I want you to keep that in mind as we're talking, because we're going to talk a lot about metric tons of carbon dioxide. And without a little context, it's hard to really appreciate what that represents. In fact, I have a visualization now that I just want to share with you to give you a sense for what all that looks like as we release it every day. And this is set on a scale model against the area of Manhattan. So if you could picture yourself flying into New York City and looking down at the island of Manhattan and all of the buildings there. This pile of carbon dioxide emissions is 1 day's worth. Let me just...
1 day's worth for the whole
1 day's worth. 1 day's worth around the globe. It's going to take a second to come up here. So 1,237 metric tons per second. When you add up all of the emissions since we really started using fossil fuels at large scale at the beginning of the Industrial Revolution, it's over 1 trillion tons that's been released into the atmosphere, and it stays there for 1,000 years. So it's just been accumulating for several hundred years now in increasingly large quantities. Now the impact of that is kind of hard for those of us who aren't scientists by training to understand until you do a little research. But we know a lot about how this works. The scientific community knows a lot about how what the impact of all that increasing release of carbon dioxide is going to be. And the way they describe it is something they call the greenhouse effect. Now, who's familiar with the greenhouse effect? Okay, so most people have heard of it. Do you feel like you could explain it to a high school science class? Anybody? Are you a science teacher?
No.
Well, we'll talk about this for a minute because I think it's worth a little bit of review, and I've actually got something to share with you that I think does a really good job of explaining it quickly, what's happening at the molecular level. But the simplest way to think about it is just think about greenhouse gases as a blanket for the Earth. And the concentration of the greenhouse gases, mostly carbon dioxide, but there are some others that make up probably 20%. The concentration you can think of as the thickness of that blanket. All right, so let's look at that for a moment.
The energy that comes from the sun is electromagnetic radiation in a broad range of wavelengths. The upper atmosphere absorbs most of these wavelengths. Visible light gets through, but a third of this reflects straight back out again, mainly off clouds and ice. So only half of the energy heading for Earth gets to warm its land and oceans. Rock, soil and water heated by visible light re-emit the energy as low-energy infrared radiation, heat. This can pass through the oxygen and nitrogen in the air. But some gases, the so-called greenhouse gases, carbon dioxide, methane, nitrous oxide and water vapor, have molecules with structures that make them absorb the radiation. Struck by an infrared wave, they vibrate strongly before releasing the energy as a new infrared wave. This can shoot out in any direction, towards space, down to Earth, or out sideways. But in every case, there's a good chance the wave will strike another greenhouse gas molecule and change course again. Although greenhouse gases typically make up less than 1% of the air, they're in a layer of atmosphere 6 kilometers deep. Not much escaping radiation makes it through without encountering at least one greenhouse gas molecule. Over the entire planet, the result of this giant pinball game is that heat stays close to the Earth's surface for longer than it otherwise would, keeping it warmer. This is the greenhouse effect. Without it, Earth would have an average temperature of minus 18 degrees Celsius, which is better than the moon, but I think you'll agree.
So that last comment is the thing that I was kind of struck by when I first understood this more fully, and that's that we have to have just the right balance of greenhouse gases in the atmosphere. And we're changing that balance rapidly when you look at it over the broad course of time. And it may feel like, well, our atmosphere is just this huge space that, it's virtually unlimited. It really wouldn't make a difference if we put that in it. But when you look at it from space, it's actually, our atmosphere is that little thin line on the boundary of the horizon. You could walk it in a day. It's like 6 kilometers, I think, is about the depth of it. And so we are putting a whole bunch of carbon dioxide and other greenhouse gases into a finite space. And it's all being evenly distributed around the globe. So this is not a local problem, it's a global problem. And as a result of that, we're changing things pretty rapidly. And I want to talk about that change in just a moment. But before we do that, I want to take a couple of minutes again and just have you, again, similar sort of exercise, just talk to a neighbor, and I'm interested in learning whether there are any new insights that came out of this for you and what kinds of questions or concerns come up as a result of those new insights. So we'll give ourselves about 3 minutes to do that again. So I would like to do what we did just a moment ago and just ask for a couple of volunteers to share the insights and the questions that your neighbor has. Okay? So who wants to start?
Well, we've gone.
Anybody? Okay.
We didn't realize that
We had over 1,000 feet of ice right here.
had such a large carbon
10,000 years ago.
impact from what we said up here.
Yeah, concrete's a very large contributor.
We also didn't understand why these gases, why do they get stuck in the atmosphere? Why don't they just keep going? Why do they collect more in the greenhouse? Why does carbon dioxide and nitrous oxide and methane, why do they, if they're the greenhouse blanket, why do they stay there?
They're very stable and they're heavy, so they don't go out, they don't escape into the space like helium will.
Okay.
But they're very stable molecules. It takes energy to break them down. It takes a lot of energy to break down. Water is not a bad thing, right?
Would you Mark,
Sorry.
you talk louder?
Sorry, stand up, sorry.
Yeah, that'd be great.
Yeah, sorry.
Thank you.
I missed the whole thing about electromagnetic waves. That's my specialty. But those molecules I mentioned, they're all very stable molecules. They got produced by some form of energy going into them, and so they're very hard to get them broken up again. So they hang around. So like CO2, plants use it, to create, but they take a lot of energy from the sun to take the CO2 and break it into something else, right? To turn it into something else. So the molecules, when they're up there, they just, unless you put more energy into them, they do something else, and they'll just stay there. Right?
And we kind of guessed because they're heavy, the gravitational pull keeps them from just keep going.
No, they keep, most of them keep, they're heavy and other stuff.
The general answer to your question is gravity.
Yeah.
Gravity keeps these things close to us.
Yeah, that's
There's
correct.
something else that they didn't mention is the wavelength of light. So actually when the wavelength of light comes through the atmosphere to the Earth, and then it bounces back, the wavelength changes, and it becomes shorter or longer or whatever, and that's why it gets trapped too, because it's a different wavelength.
But I like the pinball game sort of metaphor, thinking about that happening up there. I had no idea, okay, that's how it works.
Yeah, but it can get in through
Yeah.
that pinball, but it can't get out because the wavelength changes.
Any concerns that came up after what you learned?
I was just amazed when you said that this lasts for 1,000 years. So, I mean, we're talking about something that's going to be with us and has been with us for a very long time. So, unless we change, make big change, I mean, it's an untenable situation, actually.
Yes, that is a good way to describe it, as an untenable situation. And with that in mind, then, I want to go into that next. I'm going to keep us on track here and happy to share more afterwards. So what we know about carbon dioxide and temperature over time is that we are now in uncharted territory, and I'll show you where we're at in a moment. But over time, and let me just explain the axes. So this is thousands of years ago, going back 800,000 years up to the present. And on the left side, the axis is temperature anomaly in centigrade. So anomaly being the change from some sort of baseline or difference. On the right side is the atmospheric concentration of carbon dioxide in parts per million. And you can just see that the two lines, one of which the blue is the temperature anomaly and the red is the CO2, they fluctuated over geologic time. Remember, we came in about somewhere in here. Humans started appearing on Earth somewhere 200,000–300,000 years ago. So they fluctuated up and down, but in a relatively narrow band. One thing we know is that when this last peak occurred, sea level was about 5 to 10 meters higher than it is now. I'm not going to say it was strictly correlated, strictly due to that change, but there definitely are differences in the environment depending the concentration of CO2. And what we've done in just a blink of an eye with all this amount of carbon dioxide we've been emitting is to increase that from about 280 parts per million to over 400 today. So it's a quick, very rapid spike in carbon dioxide. Question?
Do the valleys represent ice ages?
Probably, but there are other things going on too at the same time. So there have been cyclical fluctuations related to things like changes in the atmosphere due to large volcanoes. So I'm not going to dwell on, I'm not trying to explain to you today all the differences over time. It's this big difference recently that we can explain because it's due to carbon dioxide emissions.
And it sure takes about 10,000 or 20,000 years for the high to go down again?
Well, again, the carbon dioxide lasts for up to 1,000 years in the atmosphere.
Get the charts to go down.
So we have caused it to spike, and so in general now we have to get it to come back down.
And how do we do that?
Yeah, we're going to spend the next 2 sessions mostly talking about that.
Okay.
Okay? So I had to do that in order to get you coming.
There we go.
Now, I want to zoom in for a moment on just more recent time because that little sliver is our time, about several hundred years. But NASA has a nice little visualization that shows how the change in temperature is progressing. Let me just go to that. And what you'll see is that since the beginning of the Industrial Revolution, we've seen accelerating rates of change in temperature. Again, blue is below the baseline, yellow is above the baseline, and not much is changing until about somewhere after World War II. And then what really starts to accelerate is in the 70s and the 80s. And then over the past 30 years, what you see is that the change is just dramatic and consistent. And it's most pronounced in the northern hemisphere in the Arctic. And I've spent some time there recently, and yeah, the changes are dramatic and fundamental. So we don't see it as much, we don't feel it as much right here, although we're starting to get some inkling of it. But it's really dramatic in some other parts of the world. Now, if you look at that change in temperature, and let me get back to where it was. And think about the impacts of that on our planet. I want to spend a few minutes doing that now, and I'm going to ask for your help with this kind of a fill-in-the-blanks exercise. So what's on the screen right now is just an ecosystem diagram that shows all the parts of our natural ecosystem. And I've covered up labels for some of the changes that are occurring. And what I'm going to ask you to do is just go with me around this chart, starting in the upper right-hand corner. And we'll talk about each part of it and what's happening. So in the mountains and in the northern hemisphere where there's ice pack, what's happening? Melting. Yeah. So, but more specifically, what we see, like in the the northwest and throughout the west in the mountains, is that the number of days when we've got coverage of snow is less during the winter. And the quantity of snow, generally, every winter is less. Now, it fluctuates, but the trend is really clear. So yeah, less snow and ice is the first one. And where the dramatic changes are happening is in the Arctic, in the ice coverage there. So now the next one over is right above the white birds, the flock of birds. So in general, what's happening to animals right now? What are some examples of things that are happening to animals that you may have read about?
Losing their habitat.
Sorry, what was it?
Losing their habitat.
They're losing their habitat.
Some of them are becoming extinct because of habitat and all that.
Yep. They're increasing. Extinction is a real problem for reasons that I want to talk about now for a moment. So, when the habitat is shifting, and so animals are highly evolved to thrive in a very specific set of conditions in a certain ecological niche. And we're changing that niche on it because the climate change is moving that niche in many cases. or maybe making that niche disappear. The conditions they depended on are no longer present. So they either have to move or they become extinct.
And it's not just the animals, it's the plants. Joshua Tree National Park pretty soon will have no Joshua trees because they're migrating north.
You're jumping ahead of me.
Sorry.
We'll get to everything through the course of this, and at the end, if we missed anything, please help us fill it in. But yeah, extinction. One of the ones that I read about recently that I just had no idea, and I think this is sort of a new understanding in the scientific community, is that the insect population is just in general shrinking. And that's particularly worrisome because insects are at the low end of the food pyramid. And so many things depend on consuming insects, fish and birds, and you just name it, that the ripple effects of that could be huge.
Well, are you going to get back to the fact that snow and icing is actually an accelerant because that's reflecting less energy away from it?
You guys know too much. So Mark is pointing out something that's called the albedo effect, right? The bright surfaces, light-colored surfaces, reflect the heat better. And having the polar caps present sends more of that heat radiation back out into space. And we're losing that, and the colors that are being replaced are darker, and they absorb more heat energy and emit it more slowly. So I don't know all the details exactly of how that works, but it goes into the category of things we have to be very worried about, which is that it's what they call a negative feedback loop.
Yep. Similar to like the forest fires that we're getting, which is also putting more carbon dioxide.
Yeah. So the next one over on the left is the changing rain and snow patterns, and it's hard to. That's kind of a very general way to describe things. I think what we see a lot more of is deluge or drought. And we're getting either heavier, more concentrated rains or no rains when we used to get rains. And I actually read recently the Seattle water utility has been tracking quantities of rainfall for a long time, and they said over the past 40 years, we're seeing an increasing amount of extreme, for us, rainfall events. So the old Seattle drizzle isn't as much drizzle anymore as it is like real big drops of water. And they're coming in more concentrated batches, which has all sorts of consequences for the sewage drainage systems in the city, which is why they track that. All right, next on the far right, where these little houses are that seem to be kind of tilting, what do you guys think that represents?
Is that flooding?
It's actually permafrost. Right, so yeah, so the permafrost is thawing in places in the north. And the result of that is, again, this is another one of those negative feedback loops, because there's a lot of methane trapped underneath in the permafrost. It's degraded over millions of years, like in a swamp, and now when it's warming up, some of that is bubbling up to the surface and being released. And the quantity of the area over which that's happening is so huge that the combined impact of all that release is potentially a really serious negative feedback loop. I didn't mention this earlier, I meant to, but methane is 28 times more reactive in the atmosphere than carbon dioxide. So think of it as like 28 units of carbon dioxide. Every methane molecule represents like 28 molecules of carbon dioxide. So it's 28 times as impactful.
Jeff, going back to the atmosphere and the changing rain patterns, you might just mention it's primarily because warmer air can hold more moisture.
Yes.
And, so it may seem contradictory, but there's a good explanation for it. And the same thing with more prevalence of hurricanes.
Can you return to that one in a moment? Because
okay.
we're going to, that one becomes really interesting when we talk about storms. So now we're over to this area where there's the picture of the trees and the fire and a dam releasing water behind it.
That'd be the Northwest.
So that sounds like us.
Right.
So what's happening here?
Well, that's more dry periods of drought, drying period of times it makes it drier and more susceptible to forest fires.
Yep. Yeah. And now there are other reasons that we're having more forest fires, but the main climate change related reason is that the season over which forest fires course our conditions can occur has been lengthening. And then the extremity of the fires is increasing for other reasons, more having to do with how packed our forests are with small, not necessarily very healthy trees. But in California, what they're seeing is that fires are becoming a year-round phenomenon. There used to be a fire season, now it's just all year. So that is one of the effects, more droughts and more wildfires. And then the next one is really over the city. So again, thinking now more about what the experiences of people in the city, in that part of the ecosystem. What do you think people in cities are experiencing?
Smog.
Sorry, which?
Smog.
Smog? I don't know if smog is so much of an issue related to, I mean, it is related to, obviously, emissions from vehicles and other things, but not so much climate change.
Wildfire, having smoke from wildfire.
Yeah, we're getting some of that, but the thing that's become severe in some parts of the world are heat waves that are taxing people to the point where people are dying in heat waves. Like Karachi, Pakistan, Tokyo had recently. And, people aren't all equipped with air conditioning, and where it really becomes a problem is in a humid climate. Maybe there's a physician in the crowd who explained that we just can't keep our bodies cool enough if it's both moist and hot. And that puts extreme stress on humans. So next one over is, coming back to your point a moment ago, so we have the picture of the palm trees sort of leaning. What's going on there? Hurricanes.
Extreme weather.
Hurricanes, yeah. Hurricanes is one example, and that's where that phenomenon you were talking about, there's a lot more water vapor over the oceans, and that creates a situation where hurricanes are going to pick up and drop a lot more rain. And that was the big phenomenon that happened with Hurricane Harvey. And then the other thing, I don't understand the mechanism behind it, but the hurricane itself can get more extreme, higher wind conditions, etc.
Well, there's more heat. The water warms up, there's more heat. The heat in the water is transferred to the air, and the turbulence becomes greater. And, it's interesting when climatologists look at a hurricane, they can judge the amount of energy in the hurricane, and they're not all equal. And you probably heard they classify them as different levels of hurricane.
Yeah. So we're getting higher energy hurricanes.
And also longer season.
And the longer season for them as well. Stronger storms, and then earlier you mentioned changes in plant cycles. You had a specific example in mind?
Yeah, the Joshua Tree National Park in California.
Yeah.
The Joshua trees can't handle the changes in the climate. They're migrating north. Pretty soon, Joshua Tree National Park will have no Joshua
trees in it. Yeah. And I don't know if they can migrate fast enough to survive.
Yeah.
And this affects us in croplands in particular too, because the seasons for certain kinds of crops are changing to the point where farmers 10, 20, 30 years ago planted different things than they can plant now. So they have to change as well. I'm going to pretty quickly move through the oceans because we're a little bit behind schedule, but this is another area that I just had no clue until I started looking into it, how the degree to which the oceans have saved us so far. Because an awful lot of the heat and carbon dioxide emissions has been absorbed in the oceans. And it's a vast reservoir that's been able to absorb a lot of that, but it's now getting to the point where we may be reaching a tipping point in the oceans where we're going to have things like huge dead zones, where there's not enough oxygen in the water and where species can't survive. We're seeing disappearing coral. A friend of mine produced the movie Chasing Coral. And that is a very powerful film if you get a chance to watch it. It'll really help you understand what's happening with heat causing the coral to get bleached, and if it gets bleached enough times, it just dies. And we now believe we will have no coral in it's a fairly short time frame, like 30 to 50 years.
I was going to recommend if people will watch it. It's called Chasing Coral. It's on Netflix.
Yeah, you can watch it on Netflix.
It's a really powerful video, and in the thing they talk about, they lost the equivalent amount of coral on the east coast of Australia. It's the same as losing the entire forest on the east coast of the United States. That's how big an area they lost in coral.
So it's a huge impact, and We've talked about some of these other things. So with warming oceans, that is a big contributor to the rise in sea level. It's like when you increase the heat in a pot of water, it rises. We talked about damaged corals, seafood, shellfish are responding to an increased level. Their shells can't respond to an increased level of acidification of the ocean waters. So we're starting to have problems with them being able to survive.
Well, just to elaborate, I mean, the whole ocean is depends upon the food chain in the ocean, from the smallest plankton to the largest fish, and you know, if we lose that food source,
So today we've been talking mostly about the impacts on the planet, and what I'm going to do, we're going to do this together next week as we start to talk about the solutions, to talk about impacts on people. So I'm going to get us to close today and sort of summarize what we know. The state of our knowledge about the impacts of climate change is pretty clear at this point. The scientific community overwhelmingly agrees that climate change is real, it's happening, and it's serious and urgent. I mean, the last part is the thing that they're really learning a lot more about recently, is that the estimates of when certain changes were going to happen are being pulled in. And all of this is done with models, right? We build a simulation of what we think might happen and start to test it. So it's slightly it's educated guesswork in some ways, because we're in territory that we've never been in before. So, but as of 2013, there was a study done where they looked at over 10,000 scientists' peer-reviewed publications, and 97% of those publications concluded that global warming is happening and human-caused. And that was in 2013. It could only have gone up since then. However, the public's understanding of what the scientific community understands is lagging severely. And I want to just explain this for a moment. So the Yale Center for Climate Communications has been tracking for over 10 years awareness and attitudes about climate change and global warming. And in 2018, what their survey found was that, whereas 97% of scientists actually agree, only 15% of the public understands that more than 90% of scientists agree. More than half the public either doesn't have any understanding, or they think that scientists also disagree about what's happening with climate change. So we have a lot of work to do to try and get everybody on the same page about what all the body of knowledge says about what's going on with climate change. And that's something we can all affect by just talking to people more about it. I mean, it might be hard to do with some people, but I think we have to talk more about this. So we're going to wrap up here shortly. I want you to, again, turn to your neighbors and share for a moment. What new insights and understandings have you taken away from what we've talked since we last broke out? And has anything changed about how you feel about the climate change challenge? So go ahead and talk amongst each other. A couple volunteers to, in particular, share, do they feel any differently as a result about the climate change challenge as a result of what we talked about today? Would you mind, you were sharing this at the table, would you mind going?
Well, the comments I made to you were that it makes more educated, but it makes me feel somewhat hopeless. What impact it is important to me personally, but as one individual, what can I really do that's going to help to solve the problem? And is it solvable in my lifetime, in the lifetime of my children? How many lifetimes will it take?
Well, thank you for sharing that, because that's what we're going to talk about the next two sessions. So I agree. I told you at the outset that I came away from what I learned over a couple of months alarmed. But I was also hopeful, because I learned about enough solutions that we have today that we can implement to really change the situation. I remain hopeful. It might just be because I have to be to get up every morning, I'm not sure. But I try to remain hopeful, and hopefully we'll have you feel more hopeful after the next two sessions. Anybody else want to share how you?
I completely concur with your comments, but I think also just from the church's perspective, I mean, we've stood up for housing issues, we've stood up for an awful lot of around the community. What can we do as an organization to also impact this incredibly important issue?
So that question we will address in the next 2 sessions. Because we're going to look at it at the community scale and at the individual household scale. And we can form climate action plans now that will have us all be better off, both as communities and as individual households. Anybody else want to share a question or concern that came up or a change in how you felt as a result of today's discussion?
Well, my partner here brought up something that hasn't particularly been emphasized, and that is the importance of education to the rest of the people, because most people have their mind made up. This is where I stand on it. You're not going to bother me with the facts. Don't bother me with the facts. I have my mind made up. And so how to get to those people and how to educate.
So just in case everybody can't hear fully, the concern is about the need for more education. And that's absolutely true. As you can see, people generally don't understand the situation very well, or at least they don't understand the accumulating body of evidence from the scientific community, and I'm working about tens of thousands of scientists now studying this all over the world. So yes, I agree with you. More education is needed. But the good news there, and I'm going to stop and share in a moment good news. So the good news there is that people are becoming more aware. There's been a big shift. Just since the inauguration of 2017, there's been a big shift towards people becoming more concerned than before. So let me just summarize and wrap up then by saying that that may be a lot to digest in one session, but there's only a small number of things you need to keep in mind about the climate change problem. First of all, it is happening now. It is human caused. There may be other things happening at the same time. It's mostly human caused. It's serious and extremely urgent. But the good news is that we can fix it. And in the next 2 sessions, we're going to talk about all the things we can do as communities and individuals to fix it. All right, thank you very much.